Good morning. Happy Friday, and welcome to today's webinar on achieving water excellence from data to decisions. Across many manufacturing sites, water is a critical utility, but that true cost of water often goes far beyond the water bill itself. It impacts energy consumption, chemical use, treatment, operations, and compliance. I think I recall Thomas Fuller back in 1732 saying, "We never know the value of water till the well is dry." But thankfully now we can understand the true cost of water, which in turn can help us understand a little bit more about the value of water. Today's session will explore how organizations can move from water data to real operational decisions through the true cost of water approach. What makes today's webinar particularly interesting is that we'll be looking at a real manufacturing case study, and we're delighted to be joined by Ian Ryan, Energy Manager and EPA Compliance Engineer at White Nutrition. Ian is an industry expert in utilities, water and energy management and has been working alongside the IMR water team since 2019. And he'll be sharing insights from 6 years of collaboration aimed at optimizing water systems and achieving water excellence at the White Nutrition site in Askeaton and Limerick. We will also be hearing from 3 members of the IMR water team. First up, we will welcome Ariana Pietrasanta, a senior water researcher who will be setting the scene for us in terms of water. Ariana is a chemical engineer and project leader specialized in water treatment and sustainable water management, and she designs and optimizes complex industrial water systems to improve efficiency and reduce consumption. Niall Milan, senior water technologist and CIP specialist, will join then to take over and talk us through what the true cost of water actually is and what it does. Niall is an industry expert with over 35 years experience in dairy and soft drinks manufacturing and is widely recognized as a CIP, which is Clean in Practice Specialist. A fellow of IFST, Niall is a leading authority in food and beverage process excellence. We will then bring in Eva McEnnes, Senior Water Researcher and fresh off presenting at the Future in Pharmaceuticals event in Johnstown Estate last week. Eva is a mechanical engineer that specializes in water optimization and excellence within manufacturing facilities. She brings a systems-focused approach to improving water efficiency, resilience, and sustainability across complex industry environments. So I think you'll agree we've got a fair lot of water expertise on the webinar today. So together, they're going to walk us through what the true cost of water process involves, what was learned over the years, and how better visibility of water systems can support better operational and sustainability decisions. If you have any questions throughout the session, please use the Q&A function at the bottom of your screen, and we'll get to as many of those as we can at the end. And with that, without further ado, I will hand you over to Ariana, who's going to set the scene for us. Welcome, Ariana.
Thank you, Gary, for the introductions, and thank you, everybody, for attending today. We're very happy to have you here. March is a very important month for water perspective. 22nd of March is the World Water Day, celebrates annually since 1993, promoted by the United Nations. This day encourages governments, industries, communities to take action to protect and use the water responsibly. To present and future generations. Every year, World Water Day focuses on different themes because water is an interdisciplinary topic that affects many sectors, including healthy, industry, agriculture, energy, and environmental. This year, the theme is water and gender. Water is a fundamental human right, and this is not under discussion. Having access to water is mean having access to food, sanitation, and dignity. However, in the recent years, water is also a critical economic resource. This plays a central role in sustainability, agriculture, industry, and energy. Water is not longer considered an unlimited and infinite resource. Today is considered a commodity like oil. For this reason, it's important to understand what is the global water distribution. On this special day, we would like it to everyone to take a moment to reflect and better understand what is the global water challenge in the world. There is approximately 1.4 billion cubic kilometers of water on the earth. That is a lot of water. We can imagine that all the water in the world is represented with these 100 drops. But 97% is salty water and only 3% is fresh water. And this is not all. In 3% water, about 69% is stored in glaciers, which are not easily accessed for human use. Around 30% is rainwater, which require extra infrastructure to access. Only about 1% is surface water. This surface water includes many resources, but only lakes and rivers are the most easily accessed for human use. That is a very, very small portion. Additionally, we must consider that many lakes and rivers are currently polluted. At the global perspective, 70% of the total water used in the world is used in agriculture. 20% is used for for industry use, and 10% is only used for domestic. And also, this global distribution is not equal for all the world. Right now, too many regions around the world are living under water stress. This happens when the water demand exceeds the supply, making it difficult to meet basic human, agriculture, or industrial needs. The question is simple. When the water demand is bigger than the water availability, the result is water stress. Today, 2.1 billion people don't have access to safe drinking water. Considering all these global channels, United Nations developed the Sustainability Development Goals. In specific, the goal number 6 is related to water. That includes many targets like affordable drinking water, sanitation, wastewater, reuse efficiency, and ecosystem protection. The target 6.4 is particularly relevant for industry, as it focuses on improved water use efficiency across economic sectors. At IMR, we work directly with companies to support these goals, making the invisible visible. Sustainability is not only about reduced water consumption, it's about understand where is the water, where is the water used, how many is the cost, and also we don't talking about only about cost, we want talking about value. The water intelligence means anticipate regulation, reduce operation risk, and improve efficiency. We work on their 3 pillars: visualization, optimization, and excellence. To summarize, industry faces many challenges: climate change, supply risk, increasing chemical, water, and treatment costs, and strict license requirements. True Cost of Water is our flagship service, a comprehensive assessment that takes all these challenges into account. My co-worker Naim Mulan will continue with the explanation. He is a water specialist and CIP optimization.
Thank you very much, Ariana, and welcome everybody. The true cost of water is something that I suppose here in Ireland, and just something to kind of go back on what Gary said at the very start, we take water for granted. We always have here because we have a lot of it. A lot of it is mostly falling from the sky and has done this winter. Certainly, if you're living here in Ireland, you'd know that. And also, a lot of the companies that we have dealt with over the last number of years doing true cost of water, their finished product has been their focus, and the actual water being a utility, a lot of them don't have full visuality on it. And that's really critical. And as Eva said, or as Ariana said there, there's pressures coming on that viewpoint where, people are being forced to look at their costs, number one, but also from a sustainability point of view, and more importantly, from a sustainability point of view, water plays a huge part in that journey. So on this slide, we see, and what we do in IMR from the true cost of water is we actually take your plant or your company and we holistically look at it and see, number one, what product you produce, how much water goes into that product and stays in it. I mean, we have good examples. Ian has an example at the end where it's an infant formula company where water is added and then taken out and you're selling a dry product. If you're dealing with something like soft drinks, or we'd say with beer or whatever, you're getting value back from selling the product. Whereas some companies, water is just a vector. It does something within the plant. It does a lot of things within the plant, but you end up, adding a lot of value to it and then losing that value. So this graph here, or this picture of the iceberg, is a very good example. The bill is only the tip of the iceberg. What you pay at the gate or what you pay softening from a borehole or whatever, is really only the start. The real big costs are underwater, literally, if you excuse the pun, certainly from an iceberg's point of view. And, if you are taking water from Irish Water or Northern Irish Water or, some other water utility, you probably will have to treat it in some way, having brought it into the company. But you're certainly going to be adding value to it. If you're a pharmaceutical company, you're going to be doing things like deionizing it, dechlorinating it, maybe Wi-Fi, water for injection, and adding a lot of high value to it. And the last slide in this, at the very end of my presentation, would show you a couple of scenarios where value is added. So you'd have chemical costs, you'll have treatment costs, storage costs. And then, there's energy, pumping, heating, cooling, drying, and then various different demands, and so on and so forth. And at the start and end of this process, you have licensing for extraction, or certainly dealing with Irish Water. And at the other end, you have effluent treatment, and you're putting it back either into an Irish Water controlled sewer system, or a sewer system, municipal sewer system, or with big companies, you have your own effluent treatment system. And there are huge costs involved in both sides of this. So this kind of gives you a very high level breakdown of how we do true cost of water. There are a couple of things that, companies think they have. They think they have good metering. They also think they have good water maps. And I think it's only when you start digging down into where the water goes in a company. This is why I said earlier on, visuality is hugely important here. If people understand where water is going, and then they can quantify how much water is going to each area, it's half the battle. And a lot of companies, start off and then they add on and they expand within the site. And sometimes it's a case of just pushing the water through the wall into the new part of the site without actually upgrading the metering and so on. So what you have in an older, more mature site is you have your water coming in. It's actually metered at source. Then if you're treating it, there is normally reasonably good metering through the treatment process to give you the potable water. But after that, on the distribution system, it can be very flaky. It can be good in some areas, but normally the big end users aren't metered properly. So what we do when we come in is we first of all, do an assessment of the site, look at metering, look at water maps if they're there, to create what's known as a water mass balance Sankey. And that shows pretty much the kind of spaghetti diagram of where water is going on the site, how much it's costing at each area, and how much is being used. So it gives you a very good high-level representation of your water infrastructure within your site, okay? And it kicks off really, I suppose, with the mapping, okay? You need to actually get a good grasp of where the water is going. And that involves primarily one of the most important aspects of this, a site walk down. And it's a bit like problem solving. With a site walk down, you involve the right people. You take with you the people who know the site. And they may be from utilities, they may be an engineering function, they may be, whoever knows that site. They may even be contractors, the likes of people like, if you have people like Veolia or someone like that on site who do your water for you. So it's very important that you get a good idea of where the water is going. If there are site P&IDs, the chances are they're probably outdated, because when P&IDs are put together, unless it's a big project, they're sometimes not updated. So the updating of that P&ID is a soft win for a company once the true cost of water is done, because we will find on that P&ID maybe new pieces of equipment or maybe redundant pieces of equipment and actually update them on the route. So you then are looking and saying, okay, I know where the water is going. I know where the end users are. How much of it is going to each area? And that's where we sometimes have the biggest challenge. If the metering that's actually been put in for on day one certainly might be still there and might be still working, but the chances are it's not connected to a central location where it can be read easily. And it involves maybe going around site every once a week to check it. The other thing is, and we found this a lot in water gaps in areas where we couldn't actually locate certain amounts of water, is calibration. And calibration in water metering is important. Maybe not as important as if water is being added into a product, but certainly very important. It should happen to actually allow you to see where water is going. And if you have metering in for 10 years and it hasn't been calibrated, it has probably drifted. Okay. So the metering gap is huge. Okay. And that's a big point in the whole process. The alignment of water standards is also very important. And, when you're doing this process, you have to be looking forward and saying at the end of this, if we do this properly, we can make AWS an awful lot easier. We can make, some of the accreditations that we can get for stewardship and for certification. It is the building block for a lot of that. So the Sankey, or the distribution, is critical because it shows you, and it's amazing when people from the plant see where the water is going, then there's a whole lot of stuff comes out as regards to how that water is used. And the consumption side of it is very interesting. It's normally really interesting when people see this Sankey and realize how much water their area is using. So the visuality and the communication side of it is huge. And we find as well, certainly in soft drinks and dairy, but also in pharma, that CIP is a huge user of water. And, CIP is, it eats into your total cost of ownership. So if CIP is running too long with rinses and so on and so forth, it's eating into your airtime, the time that you're actually producing product. It's also producing huge amounts of hydraulic load on your effluent plant. And that is something that you have to look at on true cost of water. That, you are actually treating everything that you're bringing in, pretty much what you don't send out in the product. So the effluent treatment cost is very, very high. And you also find in some pharma plants where they're adding a lot of value to water by making water extremely pure. They're then just dumping that water to drain after it's been used. Whereas there is huge potential left for reuse on that water. Whereas in pharma, it is very difficult maybe to change processes because of regulatory and because they're so tightly governed and also validated. Therefore, the benefit really is reusing that water on a secondary or a tertiary purpose. So my final slide really shows you the different bands, which most of you are probably very familiar with, of water at the gate from Irish Water. And, you're looking at the usages up to band 5. You could be up to 250,000 per year at the gate. But when you look then at what you're doing with that water, if you're running it through a reverse osmosis system, take potable water, could be, you could be paying €5 a meter cube for that. But then you start putting it through RO and then chilled water, or even getting hot water and effluent. There's a huge package there of cost that we just take for granted. And, even if you're taking your water from a river and treating it, or taking it from borehole, that you don't have the Irish Water at the gate side of it, you're adding an awful lot through treatment, through pumping, and also through heating, cooling, and so on. And eventually, after doing all those good things with it, you're putting it back through effluent, and you're being charged roughly a third of your total cost by doing that. So the true cost of water is a really beneficial journey. We've had great feedback in a lot of the companies that we've done it for, And you're also embedding something there that they can continue on themselves. And from a sustainability point of view, that figure of the water visuality and where they can save water and cut back on water, is a huge, it's a huge, I suppose, figure to be able to give them. So listen, thank you very much. At this stage, I'll hand over to my colleague, Ava McGuinness, who will continue with the presentation. Thank you.
Hi all, I'm Eva McInnes, as Niall just said there. Thank you so much, Niall, for that introduction. So as Niall was just saying, the true cost of water is an excellent tool for manufacturing companies to work towards their sustainability goals and their water stewardship on site. Wyeth is a great example of the power of understanding the true cost of water. So Wyeth is a Nestle infant formula based in County Limerick. We started working with Wyeth in 2019 as there was a lack of understanding around how much was being spent on water and a lack of visibility on the significant water users. Wyeth takes directly from the River Deal, as you can see in the photo there, in Limerick. So all the water and wastewater is treated on site. There was an understanding of the maintenance and labour costs associated with the treatment facilities, but many other expenses were completely overlooked. This led to hesitation to chase water-saving projects as it was considered a low-cost, infinite resource, and the return on investment wasn't realised. The leadership team on site were very driven to change the perception of water on site and to reduce the use sustainably, while also taking in the community in the surrounding areas into consideration. As with the withdrawal from the river, it was directly impacting them. So in order to deal with these issues on site, the true cost of water process was carried out, and this has been updated every year since then. This allowed for new projects to be highlighted. Some of the projects that have been carried out include reverse osmosis reject reuse, CIP optimization or cleaning in place optimization, seal water reduction, and the Alliance for Water Stewardship was implemented on site. The Alliance for Water Stewardship calls for continuous improvement on the site's water balance and water quality, along with many other things. And the true cost of water helped highlight the areas that would allow the site to achieve these outcomes. Just to highlight the first two projects I have here on this slide, reverse osmosis was highlighted as a high cost, high loss system through the true cost of water process. Although the site had installed a recovery skid already, there was still a high percentage of water being rejected to the drain. This water was then rerouted to an effluent fat sump for reuse on the site. It reduced the use of potable water by over 20,000 cubic meters a year, and it avoided the generation of effluent by over 7,000 cubic meters a year. After the true cost of water was carried out, then the true cost of CIP was carried out, as CIP was seen to be a significant water user, using over 40% of the total waters on site. Water was reduced significantly after the cost was realised through baseline surveys, verification studies, and lots of quality testing. The water was reduced without compromising the quality of the process. And not only did it lead to a more efficient system, it also gave process areas more time back for production. There we go. So as I mentioned previously, the Alliance for Water Stewardship standard calls for sites to continuously improve. It is a globally applicable framework for major water users to help sites understand and improve on their impacts, not only on the site and within the gates, but also within their community or in their catchment. After calls for Nestle to implement the standard, Wyeth started their water stewardship journey in 2019 and were certified to the standard in 2020. They were the first site in Ireland to be certified, and they have maintained their platinum certification over the last 6 years. So the dedication to water excellence on site has resulted in water use being reduced by over 50% since 2019. In 2025 alone, Wyeth's reduction in water use resulted in a reduction of 20,000 cubic meters of CO2 and almost 400,000 euros were saved by reducing their water. They've held platinum certification, as I've said previously, since 2020, and which is the highest certification you can get in the standard. And they were also awarded the Sustainable Water Achievement Award at the Green Awards in 2024. They have been finalists for this award for the last number of years as well. As we've seen, Wyeth is a great example of the true cost of water and water management. Through all the hard work and dedication to the process, they've managed to reduce their consumption by over 300,000 cubic meters, have saved almost €2 million, and have reduced their carbon emissions associated with water by almost 115,000 kg. So I am going to hand over to Ian Ryan, who, as Gary said in the beginning, is the EPA Compliance Engineer and Energy Manager in Wyeth. He'll talk you through his experience with Wyeth, with IMR over the last few years. Thanks so much.
Thanks, Eva. Good morning, everyone. Okay, you're very welcome, and thanks for the introduction there, Eva. And I'll go through these slides, guys, and I have some details on the projects at the end. I've left in the slide deck here, so you can see what we did practically over the last number of years. But look, we all know why we're here. I think Adriana has alluded to it. We know there's a major problem with water scarcity across the world. A lot of people in water stress, and indeed Ireland even seen it last summer. I think there was 14 at one point. Irish Water said there was 14 water basins in Ireland that were actually below acceptable levels. We had quite a dry spring, no fear of it this year though. So we know why we're here. I suppose the journey on site for us, a lot of the site has always been very involved in water. It's a key raw ingredient in our product. I suppose there's very little of it left in our final product as we dry it out, but without water, the factory just wouldn't function. Indeed, it's one of the main reasons it was built there back in the 70s. From a formal point of view, a lot of water fell under our ISO 50001 system. Water was kind of managed within that, and indeed it still is to a certain extent, but the business decided that the Alliance for Water Stewardship, the AWS standard, would be the standard across all of the sites, and sites would start working towards attaining that standard. So that was announced in 2018 on the site, and 2019, World Water Day, the Alliance for Water Stewardship launched their 2.0 version of the standard, and indeed they're today launching version 3.0 of the standard. So we waited till 2019 in effect to certify against the 2.0 standard. We did that certification in 2020. September 2020 was meant to happen on the 18th of March. As we all know, what happened around that time, it didn't happen. So we were the first site in the world to be certified remotely back in 2020. And we've continued that journey over the last number of years, recertifying and maintaining the standards to platinum standard. It's had a great impact on the site. I suppose the key pillars of the AWS standard is regulatory. Obviously, we have to do our compliance stuff, reputational, physical pillars, and financial. What's very different, and you'll see as I'm going to speak about next, is that with AWS, the majority of your work, if you're a mature site, and the majority of the focus is actually outside of the factory walls or outside of your manufacturing facility. A lot of this work with community, work with stakeholders, and understanding the catchment, and indeed the sources of your water to your site. So I think it's particularly applicable on sites that don't have municipal supply, where an impact in their catchment can impact their site directly, as we've seen back in 2011, where we had contamination in the river with diesel contamination, a diesel spill, and it shut our factory down for 6 weeks back then. We have a bit more robust systems in place now to hopefully avoid that happening again, or at least avoid the impact of the factory. So how it's applied in Askeaton, look, we do a lot of work with the community. We'll speak about that in a minute. We are technically in the river dealing in that catchment, but we're also part of the Shannon estuary. So the river you see there, as Eva showed a nice picture of earlier, to the right is actually tidal and actually estuary, and that's actually salty water. So we take our water above the village of Askeaton, 2 kilometers from the actual factory. Why connect with local stakeholders? What's the advantage to this? So we're a major employer in the area. We are the very last user of water, effectively, on the river. So everything that comes down the 70 kilometers of river Deal arrives down to us. And unfortunately, that river quality has been dropping and dropping and dropping over the decades. And I suppose there's a big focus now on trying to improve those rivers with poor water quality. And the impact of that. So like why we're in there. So concerns raised over swimming. So there is a local swimming club in Askeaton. It has had to cancel, and it's been a good few years since it's actually ran a regatta now. With the river has recently it's got into trouble now with cryptosporidium and other contaminants, and ultimately they're all driven by eutrophication. The sewerage scandal in Askeaton. Yes, we would be aware as part of the AWS process of at least 8 points in the town of Askeaton where raw sewage is dropped straight into the river without any processing whatsoever. And then another example here is the serious fish kill in County Limerick. Now, that wasn't the river deal, but it was our sister river, the River Meg, and they set up a river trust on the back of that. But we've seen other serious fish kills around Mallow and there in North Cork in recent times. So look, if water is important to your business and you're abstracting that water, even if you're getting it through Irish Water, they're abstracting it from the catchment in some shape or form. It's good to be invested in that. And as part of that, I suppose one of the exercises we did was mapping out the key stakeholders. Look, it's mapping is pretty easy. You kind of just look at everybody that has an interest in the river or lake or whatever your water source is that you're getting a water from, and looking at what their influence are. There's some that are very obvious, like the EPA, obviously the local county councils or Irish Water, and then all the users that are on the river. It's a very good exercise to do if you're thinking about standards like AWS or EWS or whatever standards you might be interested in. Mapping them is straightforward enough, and it's a continuous process. We're still adding people to the list of key stakeholders in our catchment. As you get into this process, you start to identify more and more of them, and you get in contact with them. The hard work is actually contacting them and introducing yourself and getting the relationships built up. And I suppose this mapping exercise in that respect is important because you're going to focus on the ones that have the most interest in the water body and the most influence on the water body. So top right hand corner, the most important people, zone 1, and then you put maybe slightly less effort into zone 2s and zone 3s. But the mapping is important. As part of that, colleague engagement. So one of our most important stakeholders is the people on site. So there's over 400 people employed in Wyatt, and this is our monthly newsletter. And we would do them, 12 a year. There would be 4 or 5 would have information relating to water. What's really come out of this, the real value in this program has been, and it's about everything environmental and sustainability. But the real value is in identifying key stakeholders on site. So we had a secretary of the Tidy Towns Association. We had through this we found a former that was now the chairperson of the local swimming club. So we identified a lot of people that are key to engagement in water in the community through colleagues on site. So they're an important set of stakeholders to keep in mind. I suppose the next step after that for us was this catchment excellence program. I'll spend a minute or two just talking about this, but the key to this was once we'd mapped out our stakeholders. That's why mapping your stakeholders is so important. It was this program we put together where over about 12 weeks we got about 20 people in a room over 6 different days. We did some training with them, raising awareness. We started the very basics, explaining what catchments are, and then right through to working on invasive species and things of that nature. With I suppose a goal to getting to shared water challenges. We got out physically out onto the river. We looked at the upper, middle, and lower course of the river. So we were right up to County Cork and seen the beautiful part of the river that hadn't been drained and hadn't had the arterial drainage work done by the OPW. The River Deal, as an example, is 70 kilometres long. 67 kilometres has been straightened and drained by public works over the decades, and which is detrimental to the environment and of the river and its health. So we'll see programs in the coming decades to restore rivers in that respect. I expect from the state, starting to put back in flora and fauna, put back in natural oxidization of the water and stopping that straightening, because really the problem with the straightening is the flow. You get a huge swell when we have high rainfall, we get a huge flow river, and then it hits the bottom course of the river and drops all its sediment out. So then you're into dredging, and you have to do it to keep it working. So in a natural river, that just isn't an issue. So I think we'll see all that happen in the future. And the ultimate output of that was a catch and action plan. So the stakeholders built an action plan of things we'd like to do, and you can see the river quite clearly there on the third slide. That's the bit that's unstraightened. There's rocks in there. There's natural aeration going on. There's plants growing in there. There's fish. There's birds. The river is very healthy at that point, and that's what we need to achieve on all of the river. And indeed, there's 70,000 kilometers of river in Ireland, all of the rivers in Ireland. Which will obviously improve the lakes and stuff by the way. So this was a great program we ran. I suppose it's more the advanced end of stuff but we never would have engaged with the community without the AWS certification and the drive, the provisions and that drove us to start this engagement, start talking to local people. You will find that everyone has these shared challenges. It's the same problems they're all seeing. It's water quality, it's eutrophication, it's surge flows, it's flooding, it's all the same problems. And when you can get them down on a piece of paper, then you can start working on them and looking for funding and engaging with stakeholders like councillors and stuff to get things done. And one of the things we did out of that was the Deal Water Blitz. So any company that has a water body in their community, which is everybody, can run these water blitzes. There are different companies that will provide them, but basically what they are is citizen science. It's something we did as part of the Catchment Excellence Programme. They're citizen science. They're very simple. We could train anyone in 3 minutes how to do it. You're basically getting out onto water bodies and you're taking samples. You're checking for nitrogen and phosphorus. The kits cost tens of cents each. You'll buy a box of them for €100. That'll do thousands of tests. You get them out to the community through your network. They go out and do a sample, and you open up a window over like a bank holiday weekend or something where people take all the samples at nearly the same time. They take photographs of the river, they load it all onto an app that's free, and that data all ultimately it goes up onto the Blitz website, but it also UCD pull that data to kind of try and build a map of how water quality is improving or disimproving across the country. But the most important bit of that they will tell you is actually the photographs. How does the river look? So you try and run them twice a year at roughly the same thing. So we kind of do them around Easter and around Halloween, somewhere around those kind of natural breaks in the year. Last little point from me, and I have a couple of slides on projects, but I leave that for you to read at home, is the journey. What's really changed with AWS for us is the journey. So it was very much just save water, projects that were initiatives around that. But we've really moved through the AWS process into building what I've called the move from the rational approach, just the saving water. Now we talk a lot more about shared water challenges. Water quality is a huge thing now. It's not just about volumes, it's about how good the water is, the impact on abstraction. So it's become quite a story and quite a journey, and we've added a lot of emotion into it, because if you don't put that emotion in, you won't get that influence with your stakeholders. It is a sales job. You have to sit down with stakeholders and you have to sell, your vision and what you'd like to try and achieve. And, and a lot of stakeholders are nervous about putting their head out of the parapet, as they say themselves, because there's always the risk that will be seen as greenwashing or whatever, but our journey definitely has helped others build the confidence to start their own journeys in this shared water landscape, and we have to see it as a shared water landscape. The strategy for us on site is this try and reduce water, which is the rational stuff. The rethink, how can we avoid using water whatsoever or use different processes, and then ultimately replace. Is there any process that we can just not use water anymore in? And obviously there is some we can't and there is some we can, but that's the strategy, and it's a very simple strategy, and we build projects around that. The water process on site is part of the mapping that Niall and Eva all talked about. A very simple map. We would have a lot more detailed ones now, but we would have started with this back in 2018, 2019 with the most basic map. I encourage people that don't have this to just start mapping out, not a P&ID, a map of just big process steps, what is there. We moved on then to the true cost of water. I won't dwell on this. The guys have it already well covered, but let's just say it was the most key thing in terms of engagement from senior leadership that we did on site. once we had a cost, we always did projects on water, but they never had a cost beside them. Once we had a cost, it was an enabler to get more funding, get more projects done, and even to get, the resources to start looking at, projects that were a little bit more involved, let's say. And I can show you a quick example of them. So we did these things. I leave these slides for you to read. Projects like water reuse. We haven't implemented this, but we've done the heavy lift and we figured it out how we break our waste streams on site to put us in a position to allow us to recover water from a wastewater treatment plant to reuse within the factory, which is difficult both technically on site because of the nature of what we make, the infant product, but actually a bigger problem from a marketing point of view, this idea of reusing water in something that's such a sensitive food category. The true cost is CIP, another project we did, huge savings on that, and indeed it is a process that can be reiterated and reiterated, and I think you can do the true cost of CIP. You can run that process 3 or 4 times. You can keep making improvements in them. And that's it for me. So I've the slides in there on the projects, guys, so you have the bit of detail, and thank you for your time today.
Great stuff, Ian and Niall and Eva and Ariana. Some really fascinating information in that. And thankfully we have this recorded so we can go back over it. We have a number of questions in already, which is not surprising. So if the panel want to turn back on their cameras, Ian, this first one is for you. What was the initial trigger for you or for Wyatt to start looking at this, and how did you find IMR to work with?
The initial trigger, guys, was very definitely corporate. Okay, so the head of operations in Nestle said that we needed to align to a water standard. We had been doing a lot of work on it. We had it kind of under the umbrella of 50,001 and using it there as a resource point of view, but we wanted to go further into the stewardship side. So Nestle said AWS is the standard, and we started working on that. And we did a lot of work to do, because it's very different than the ISOs. If you haven't done stewardship standards, there's a lot more grey and a lot of our time and resource was spent talking to people, meeting people, selling the idea, getting engagement, making it very clear that we weren't greenwashing here. We were actually trying to figure out what the problems were in the catchment and trying to, be a force for good within that. There was a second part of that question, Gary.
How did you find IMR, I suppose?
Yeah, well, I'll be honest. I had a previous relationship with one of your colleagues there, but I was aware of the organization and the work they were doing in the space, so we reached out to each other, and never looked back. Yeah, been a great relationship since. Yeah.
Great to hear. How do I know if my company is big enough or uses enough water for this type of service to be relevant? And I'll just add in this to what companies should be looking at taking on a true cost of water project. Ariana, do you want to go ahead with that?
Yeah. Any factory can apply true cost of water concept. It's not about how much water is in use. It's about how the water is used. It's a comprehensive assessment with a focus in efficiency, loss, reuse. It's how to identify new opportunities. For example, right now, data center are very, very good examples. A few years ago, nobody thinking in the relationship with the data center and the water use, and right now it is a very, very critical. Water plays a role just electricity. I mean, with this is more about visualization and planification, and not all in how much water is in use.
Great, thank you for that. Next question is there funding available for this type of project?
Yeah, I can go on that, Gary. So there are a few different funding mechanisms through the IDA and Enterprise Ireland, such as Green Start and Green Plus. So if you're looking at operating more sustainably, reducing your water usage, your energy use, your carbon emissions, you can get funding from that, and that's something we can help you walk through.
Excellent. So if you are looking for a project like this and looking for help with funding, get in touch with us on that as well. What would you see as the biggest impact that taking on the true cost of water has had on Wyatt? So Ian, I'd say that one's back at you.
Sure. Yeah. Look, real honestly, it got finance to the table. That's just the truth. We had done water projects in the past. Some were compliance, some were just upgrades. There was savings in them just natively, but water became a proper vehicle for making savings on the site. You've seen the figures there from Eva, like nearly 2 million over the last number of years in water, and that's just ultimately reduction, because it is a per cubic meter cost in general. There are some fixed costs in there, but there's a lot of variable costs in there. It got finance to the table. It got the delivery and implementation of water projects on the site a lot easier to get over the line, because you could put a proper payback on them. And I suppose the success with the first few projects with those paybacks really just made the next one so much easier. So you're pushing an open door when you have the true cost. It's science, and it's not, well, it's a good thing to do. It's moved the narrative completely on site.
Great. Just in addition, I think for the funding question, Katrina Powers put in that manufacturing clients of Enterprise Ireland can utilise the EM&T metering grant to cover costs for installations of water meters. Thank you for letting us know that, Katrina. Okay, next question that we have up here is, how do you decide which water management system to align with, e.g. ISO 46001, AWS, others?
Honestly, it's very simple. I take a look at them all, and I suppose it depends on the resources and availability. Like AWS is not a light standard. It takes serious resources to deliver it. If your site's smaller and resources are tighter, start with something you might know a bit better, like 46001. It's aligned with all the other ISOs. If you're already doing 9,000 or 45 or 50,000, like, you have a fairly good idea of the process. But there's value in all of them. It'll only take you a few hours to read through the AWS standard, and you don't even have to go for certification. Pick out the bits that have value to you and take them. Certification's nice, and you don't. It's one of those certifications you don't have to have. Well, not yet anyway, but it's nice. But I suppose once you get a site certified to any standard, then there's a natural drive then to maintain that, and then that just keeps the processes rolling. And as the processes are rolling, they become embedded, and if they're embedded, then you don't even know you're doing them anymore. They're just part of normal business. So I wouldn't particularly push any particular standard. AWS was imposed on us, you could say, thankfully, because it's complicated, and it made us look at a lot of weird stuff you wouldn't look at normally, and that's been interesting and driven people on site, kept them interested. But pick the best of any of them. Certification's a bonus. If you're getting all the value and you're not doing the certification, so what, you're doing all the good stuff, that's fine. So whatever works for you. There is many standards around water that you can work towards. They're two of the best I've seen, though.
And Declan had also just asked, well, he said very good presentations by all, very informative. Is there many other companies in Ireland having the AWS standard? I think there's only one other one in Ireland, is there?
There's only two at the moment. I'm aware of a lot of people working for it and towards it. It's in terms of standards, it's a relatively new standard. It's only about 10 years old. So from a standards point of view, that's not very mature. Now, they're literally releasing, because World Water Day, they're literally releasing 3.0. So we're all holding our breath to see what's in 3.0. One of the things that will be said about 2.0, and they'd say that themselves, AWS, is it was difficult to audit. It was a very, very difficult standard to audit against. All the auditors would tell you that after being through 6 of them. I couldn't tell you that. So the hope is that 3.0 is a bit more streamlined from an auditing point of view, and that'll take down some of the costs and some of the resource burden. But yeah, we need to. I think a lot of people will be reading 3.0, and there's a lot of people that are probably ready to go on certification. They just haven't pressed go. I'd be aware of 5 or 6 others, which in a country the size of Ireland for an international standard, that's pretty good. Like
version 3, I've had a read through it of myself, and they're implementing a lot on biodiversity and everything, as well as all the water savings and water within your catchment. So it's aligning a lot with the new CSRD and a few of the ISO standards as well. So I do think there'll be hope that more people will take on AWS, but it is, as Ian said, it's a lot of work, and it makes sites kind of, you have to be a little bit more open with your community than some sites would prefer to be sometimes.
Thank you, Eva. Regarding effluent treatment, ETP is not using much energy for hydraulic load, but the major part of energy is used to remove contaminants, which is not directly proportional to hydraulic load. If you reduce hydraulic load, savings on power consumption will not be directly proportional at all. Also, non-biodegradable fraction of COD at outlet from ETP will increase, which will have impact on compliance. And are you taking this into account?
That person, Gary, I don't know who wrote it, but they know what they're doing. They've so I hope there's no one from the EPA listening, but dilution is not the solution. But you're right. If you're reducing water, then in theory, your influent then becomes more contaminated, as in there's more waste per cubic meter or more nutrients per cubic meter, right? Completely right. You do have to tweak at your wastewater treatment plant. We've seen it, hydraulic loads drop when we've had to make changes. There is an energy impact on that. And yeah, we've done some stuff around working on that. Operationally, yeah, I ran the wastewater treatment plant on site for 6 years. Operationally, we put in more DO monitoring so that our VSD and our blowers were running closer to the set points. There was less variation in how DO control was done. So yes, it is the short answer. There is an impact on that. But yes, they're totally overcomable. And in general, you will see over time, we would do one of the metrics we would use for a wastewater treatment plant would be kilowatt hours per COD. So we monitor that and keep an eye on that. Generally speaking, a reduction in hydraulic load will reduce energy usage to a point anyway. There is always a minimum hydraulic load that has to go through a wastewater treatment plant, not always in the manuals, and we've seen that as well. There's this kind of flushing process in most wastewater treatment plants where the biomass needs a certain amount of hydraulic load to operate. So yeah, there could come a point where you start really running up against the ground in terms of your wastewater treatment plant and maybe having to downsize it and make some process changes. But you know what? That's a great problem to have. If you're getting to that point, you're fixing all the other problems upstream. I remember a lot of, as you've seen from Niall's presentation, a lot of the cost and value is is going into that water before it arrives at the wastewater treatment plant. So from a business point of view, if you can save the water, you're saving a lot of the cost, and you may have to invest some of that in changing how your wastewater treatment plant works or tertiary treatment processes, which might be imposed on your regulatory anyway. But yeah, I think you cross them bridges as they start to arrive. You can plan ahead for some of them, but in general, I think all overcomable, and there's a lot of technology and a lot of expertise in Ireland to help with that.
Yeah. In the truck of water, we are full recognized EPT operations and all the costs involved in the effluent, like electricity, energy, all the license, all the maintenance. But like Ian said, the dilution is not the solution. So we are trying to minimize as much as possible the total effluent. The ideal is net zero, and it is two different things: the efficiency inside the factory about the water use and the efficiency in your EPT plant. Our objective is have the minimal total effluence.
Excellent, thank you. Well, we're just gone past. We do have more questions, but we will get back to you by email. So there's questions from Stefan, Kieran, Jim. You asked, are the slides going to be sent after? This has been recorded, so we will get the recording out to you. And if you still want the slides after that, just let us know. But for now, I'd say that we've probably been through enough. I don't want to keep everyone too much longer, so I just want to say a huge thank you again to all of our speakers. Ian, Ariana, Niall, and Eva, and thank you all for joining as well, and hope to see you again soon, and wishing you a wonderful weekend.
Thanks, Gary. Thanks, everyone.